Alright, so I know some of you are having questions on changing bases. So here, for instance, for the first case, if you're converting from, for instance, 43,735 base 8 to decimal form is also your base 10, the form that we normally write our numbers in. This way is normally a little bit easier to understand. What you do here is you do 4 times, and to figure out what exponent you need on those 8s, what you do here is this 5, for instance, would have an exponent of 0 on the 8. The next one over, the 3, would have an exponent of 1. 7 would have an exponent of 2, and so on. These exponents keep increasing as you go further to the left, as those values are getting bigger as you go further to the left. So here, for instance, for the 4, we'd have it 4 times, and then we'd have 8 to the 4th power. So remember, the exponents always start with 0 and then work your way up. So then plus, for the 3, for the next digit over, we'd have times 8 to the 3rd, plus, and then for the next digit, the 7, we'd have it times 8 to the 2nd power, plus, and then the 3 would be times 8 to the 1st power, plus, and then the last one would be 5 times 8 to the 0 power. Remember, anything to the 0 power is 1, so that last digit there is not a 0 there, as you may think otherwise. And then you want to go through and calculate, see what you get for answers here. So I'm going to go ahead and type it in here. So it looks like here for the first calculation here we get 16,384, and then we're going to plus, and then the next one is 1,536 plus, and for the next one we get 448 plus, and then 24 for the next number, plus 5 for that last digit. So for your final answer here, we should get 18,397 for your final answer here. So I'm going to circle this part here. So this part here is what your final answer would be, that 18,397. And like I put in the directions here, you don't have to worry about the calculator shortcut method, because some of your calculators, it's actually going to be harder to enter it that way. So you can certainly use this method, and if you can't get that way to work for the calculator shortcut for the homework, you can skip that part. I won't make you do that on the test or the quiz, and then just send it to me with the Ask Instructor link, and I can go ahead and give you credit for that part of the problem. But you do want to make sure that you still continue on the problem, because there's one more part after that for writing out the final answer. So make sure that you are still going through and get to that last step for writing out your final answer for those problems. I think those are numbers 2 and 3 in homework 4.4. So then for the other example that I want to do right now is to convert, for instance, the number 2015 to base 3. So this way is the way that normally gives more students trouble. So one way to do it, the way that I normally do it, is I use what they call repeated division. So what you do first is you write out the 2015, and then instead of dividing it with the long division sign the normal way, we do it as upside down, because we're going to keep continuing this division here. So we're going to go downwards instead of upwards. So that way then we can go through and keep this division going, because we don't necessarily know how many steps it's going to take us at first. So that's why they go down instead of up here. So you're always dividing by whatever this base is that you're converting to. So here in this case we're converting to base 3. And then whenever you're dividing it out, what we want to do is just write the whole number part underneath there. So if we do the 2015 divided by 3, the whole number part of that is 671. Do not write out the decimal points. And then off to the side here, we have to write out what our remainders would be. So one way to calculate out our remainder, so I'm going to put R off to the side for remainder, is to do whatever number was inside the division sign. So in this case here, this 2015, so I'm going to highlight it there. So our first number there, 2015, minus, highlight where that number was coming from there, 2015, and then minus the 3 times the 671. Because what you're trying to do is figure out what is left over once you divide that 2015 by 3, what's left over there. So if you calculate that there, so we'll put these in pink here for the highlighted part there. So you'll do a similar steps for the other ones there, just to help organize it a little bit. For that remainder there, you should get 2. So if you do that 2015 minus the 3 times 671, you should get 2 for that first remainder, and we'll write that right beside that 671, since that was the remainder for that part. And like I said, you keep repeating this until you can't divide the number by that outside number anymore. So this time we're dividing by 3 again. If we do 671 divided by 3, the whole number part there is 223. And once again, if you need to, if you're not sure what the remainder is from there, you can calculate it out. This time we're going to do the 671, since that's the number inside the division sign this time, minus 3 times the 223. So this time we're using this 671 again, but then I'm going to switch colors here to the light blue. This time we're doing minus the 3 times 223. So I'm not going to highlight all of them, but just the first couple to help you see where those numbers are coming from. So here, once again, if you calculate that, you should get 2 there again. And keep in mind that all of these remainders have to be less than whatever that number is you're dividing by. So in this case, we're dividing by 3 to get to base 3. All of those remainders should be either a 0, 1, or 2, because all the remainders have to be less than whatever base you're converting to. So if you get a number that is greater than or equal to that base, then you did something wrong. You didn't have the largest number in there. And then once again, keep repeating this process. I'm going to start going a little bit quicker here. So here, if we divide that out, we get 74. For the remainder here, you can do that 223 minus 3 times 74. Like I said, not all of you will need to go through and do this calculation to get to your remainder. But if you're not sure what it is from the decimal, you can certainly go through and calculate it out. For that one, we get a remainder of 1, and then divide by 3 again. So these ones can get kind of long depending on what the number is and what base you're converting to. So here for the next one, then we do the 74. That was the number we were dividing by, or dividing into, I should say. And then we're dividing by 3, and then we get 24 for the whole number part there. So for the 24 there, we get a remainder of 2. So we'll write that beside there again. And then divide by 3 again. And we get 8. So here in this case, there is no remainder because it ends up being a whole number here once we divide it by the 3. So what that means is that the remainder here is 0. And you do need to make sure you still write that 0 in there as part of your work. Don't just leave it blank. Make sure to write in the 0 whenever you get a remainder of 0. And then divide by 3 again. So there we get 2 for our remainder there. If we do the 8 minus 3 times 2, we get a remainder of 2 again. And you'll notice for this last one, if we try and do the 2 divided by 3, in that case, we don't get a whole number there. In fact, we don't get any whole number before the decimal point. So that means this 2 is then the final remainder. So you want to make sure whenever you're dividing these out, that you're going through and writing out that final remainder as well. So then for your final answer, to read off your answer, you actually go from bottom to top whenever you're writing out that answer. Because remember, these repeated divisions were going down instead of upwards. So to read off your answer here, so let's read out answer. We would get 2, 2, 0, and then 2, 1, 2, 2. So once again, 2, 2, 0, 2, 1, 2, 2, then would be your final answer. Like I said, you don't have to necessarily show the work for the remainder calculations there if you're able to see what those are on your own. But on a quiz or test, you would definitely need to show that work for the repeated division, what your remainders are, and also what you get for your final answer. Make sure, like normal, if you do have questions on this stuff, that you are asking.